MongoDB Atlas incident on August 9, 2023, a DevOps Postmortem. It's 13 UTC on August 9, 2023. You're sitting in your chair when the monitors start screaming not just a single fluttering alert, but a systemic hemorrhage across the global infrastructure. In an instant, the Atlas control plane begins to buckle under the weight of a botched configuration change. This isn't some localized hiccup, it's a cascading failure spiderwebbing through multiple regions simultaneously. Connectivity starts dropping like stones, and error rates spike as users worldwide find their applications suddenly hitting brick walls. By 13:08, the all-hands alarm is officially pulled. The scale of the chaos is massive, threatening the backbone of dozens of different platforms at once. We don't know yet that a routing bug is the culprit lurking in the code. All we know is that the heart of the system is skipping beats, and every second of downtime translates into real-world chaos for everyone relying on MongoDB Atlas. Imagine your entire application's backbone, the database that holds every user profile, every transaction, and every piece of vital metadata suddenly starts gasping for air. That was the reality for MongoDB Atlas users on August 9, 2023. For those just starting out, think of Atlas as a massive, managed cloud service where companies host their data. If it goes down, the customer's business literally stops moving. On this day, a botched configuration change to the Atlas control plane triggered a cascading failure across multiple regions. It wasn't just one unlucky cluster. It was a systemic breakdown involving network routing that crippled connectivity for countless organizations simultaneously. When you have thousands of applications relying on a stable connection to fetch data, even an intermittent issue feels like a full-blown emergency. By the time the clock hit 1300 UTC, the gears were grinding to a halt, and the chaos had officially begun. It started like any other Tuesday, the kind where everything just works, and you forget how fragile the underlying plumbing actually is. For most users, MongoDB Atlas was a stable bedrock, but beneath the surface, the team was preparing for growth by updating the infrastructure. At exactly 1300 UTC on August 9, 2023, they pushed a new configuration change to the Atlas control plane. It was supposed to be a routine update to network routing, nothing that should have set off alarms or woken anyone up from their lunch break. But as those lines of code propagated through the system, something went sideways deep in the logic. What began as a standard deployment quickly morphed into an invisible rot, seeding a cascading failure across multiple regions. The before was quiet. The after was about to get very loud very fast. They didn't know it yet, but the storm had just landed. It started with a quiet, push-a-routine configuration change to the Atlas control plane that nobody expected to turn into a grenade. At exactly 13:10 UTC on August 9, 2023, the first alerts began screaming across the consoles as the deployment hit the network routing layer. It wasn't just one cluster, it was a cascading failure spiderwebbing across multiple regions simultaneously. By 13:08 UTC, the situation had escalated enough for the official incident response team to jump in. For those watching the dashboards, the data didn't lie. Connectivity was becoming intermittent and error rates were spiking globally. The engineers weren't looking at a localized hiccup anymore. They were staring down a systemic breakdown of core networking components. In those opening minutes, the normal state of the platform evaporated, replaced by the frantic reality of a widespread service disruption that threatened to take everything down with it. It started with a single push-a-routine configuration change to the Atlas control plane that should have been a non-event. But at 13:10 UTC on August 9, 2023, the logic folded like a house of cards. A software bug buried deep within the network routing logic didn't just trip a local wire, it triggered a cascading failure that bled across multiple regions simultaneously. By 13:08 UTC, the intermittent connectivity reports were screaming loud enough for the response team to officially declare an incident. The problem was systemic, radiating outward from the control plane until users everywhere saw their error rates spike and connections drop into the void. It wasn't just one cluster failing, it was the very fabric of the regional infrastructure buckling under a faulty routing instruction. It took until 1400 UTC for the rollback to finally take hold, slowly pulling the system back from the brink as services began to crawl back to life. So, what actually broke the gears? It wasn't some freak act of nature or an overwhelming surge of traffic. It was a classic case of the update that shouldn't have. At exactly 13 UTC on August 9th, a new configuration change was pushed to the Atlas control plane. The issue lived deep within the network routing logic, a software bug buried in those specific instructions. Instead of just updating one segment, this flaw triggered a cascading failure that ripped through multiple regions simultaneously. Because the core networking layer was compromised, connectivity became intermittent and error rates spiked for users across the globe. By the time the team engaged at 13:08 UTC, they were fighting a wildfire caused by their own deployment. The faulty route essentially orphaned parts of the infrastructure until the rollback began at 13:20 UTC. It's the kind of technical debt where one bad line of config becomes a multi-region nightmare. When that botched configuration hit the Atlas control plane at 13:00 UTC on August 9th, it didn't just trip a local alarm, it triggered a cascading failure across multiple regions. We aren't talking about a single flickering light. This was a widespread service disruption that hammered connectivity for users globally. For roughly 2.5 hours, the infrastructure became a minefield of intermittent connections and spiking error rates. The blast radius here wasn't localized. Because the bug lived in the core networking routing, it had effectively choked off access for various clusters simultaneously. It took until 15:30 UTC before every affected service was finally stabilized and restored to normal operations. While we can't put a precise dollar amount on the chaos of those 100 minutes, the reality is clear. When your primary control plane fails, the impact ripples outward until someone pulls the plug on the bad code. The clock hit 1300 UTC on August 9th, when that first wave of alerts started screaming across the dashboard. It wasn't a gradual crawl. It was an immediate fire sparked by a new configuration change hitting the Atlas control plane. By 13:08, the situation moved from anomaly to full-blown crisis, and the incident response team was officially engaged to handle the fallout. They weren't just fighting ghost bugs, they were battling a cascading failure caused by a networking routing flaw rippling through multiple regions. The pressure was palpable as they hunted for the source, while connectivity began to crater for users everywhere. At 13:20, they finally pinned down the faulty config and pulled the trigger on a rollback. It worked. The gears started turning again at 1400, with services gradually stabilizing until the dust settled completely. By 15:30, it was a brutal exercise in damage control under the heaviest of spotlights. The clock was ticking fast once they pinned the culprit on a faulty network routing configuration within the Atlas control plane. By 13:20 UTC, the engineers moved with surgical precision to initiate a full rollback of that specific deployment. It worked. The system began breathing again by 1400 UTC as the rollback propagated across the various affected regions. But fixing it didn't mean just walking away from the wreckage. To stop this nightmare from repeating, the team overhauled their validation pipeline for core networking components. They aren't just hoping things work anymore. They're implementing more rigorous testing and enhanced observability to catch these subtle anomalies before they cascade into global outages. They also optimize their rollback mechanisms to slash recovery times even further. Now, there is a much heavier emphasis on regional isolation, ensuring that if one part of the beast catches fire again, the rest of the world stays standing. Look, if there's one thing this mess taught us, it's that it worked in staging isn't a shield against reality when you're messing with the control plane. That botched network routing change didn't just trip a wire. It triggered a cascading failure across multiple regions because the safeguards weren't deep enough for core infrastructure. We see the cost clearly in the timeline from the first alert at 13:00 UTC until full restoration was achieved at 15:30 UTC. Every minute was a battle against their own configuration error. The takeaway here is brutal but necessary. Your blast radius must be contained by design. This means moving toward stricter regional isolation so a single bug can't paralyze everything. It also means faster rollback mechanisms and granular observability to catch those subtle anomalies before they snowball into a multi-region nightmare. Don't let a single bad push become everyone else's catastrophe. That's how MongoDB turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.